Hello guys, in this video I am going to explain the solution of this question number 26 from chapter 11 AC Circuit Power Analysis from the book Engineering Circuit Analysis by Hayt, Kemmerly, Durbin. So the question says that we need to determine both the average and the RMS value of each waveform depicted in figure 11.36. So these are the two waveforms. So over here both the waveforms are periodic, means it is not completing over here. Remember, it is not completing over here. Since there are two peaks, so it means that it is continuing like this, right? So it means we know that for the periodic signal we just need to determine one period. Means like over here you can see that if this is starting from this point, now at 3 again it is repeats itself. So it means that the period time period of this waveform, it is 3, because after 3 seconds, it is in seconds, so after 3 seconds the waveform is repeating itself, right? And we also know that for the periodic signal, when we calculate the average and the RMS value, we just need to calculate the average and the RMS value only for one period, right? So over here I will calculate the average and RMS value only for this duration of from 0 to 3 seconds, right? Now when we talk about the average value, the general formula for calculating the average formula, it is given as 1 upon T2 minus T1 integration from T1 to T2, and whatever is the signal, let it be IT and dt. So with this we are just calculating, we are just taking the sum, right, or the area of this, right, and with this term we are just dividing with the total time period, means it is means total sum divided by time, right? So it will give you the average. And the RMS, the formula for the RMS, to calculate the RMS value, it is given as under root then mean over here, then integration from T1 to T2, and then it is I square dt, right? So these are the general formula. And over here, like since T2 minus T1, so over here our T2 minus, or for the first case, for this case our T2 it is 3, our T1 it is 0, right? Because it is 0, it is 3. So these are our T1 and T2. What is our IT? Now if you look at this over here, this is given 9 over here, this is given 9 over here. So it means since it is negative, so we can take this as minus 9, right? So this particular this IT can be expressed as like it is 0 for t less than 2, and it is minus 9 for in between this, right, for one period. So now using this expression of the IT, we will substitute this in this formula. How? Over here 1 upon 3 minus 0 integration from 0 to 3, and then IT dt. Now what is IT? IT is 0 for less than 2, and it is minus 9 for in between 2 to 3. So we can divide this integration. How? It is 1 by 3, and then we can write it as like from 0 to 2, it is 0 into dt plus integration 2 to 3, and then the value of this IT, it is minus 9. In between 2 to 3, it is minus 9, right? So I will put this, so it is dt. Now it is 1 by 3. This expression, since it is 0, so it will become 0, plus. Now the integration of minus 9, it will be 90 minus 9t with limits from 2 to 3, right? So it will be 1 by 3 and it is minus 9t. So taking 9 into 3 minus 9 into 2. So solving this, we will get 1 by 3. So minus 27 plus 18, right? So it is minus 9 upon 3. So it is minus, sorry, it is not, yes, it's right, yes, it is minus 3. So this is the average value. And what will be the unit? Unit will be, if you look at this, the unit of a current is milliampere, right? So the unit for this will also be milliampere, right? So this is the average value of this. Now calculating the RMS value. If we look at the RMS value, just a minute. Yes, milliampere, right? Now again we will simply substitute the value 1 upon 3 minus 0 under root, and over here this is integration. So instead of writing again this 0 to 2, right, 0 to 2, I will straight away write the limit from 2 to 3, because from 0 to 2 limit is, from 0 to 2 the value is 0. So in between 2 to 3 the value is minus 9. So it is minus 9 square dt, right? Now 1 by 3 it is 81 dt, limit 3 to 2, it is equals to under root 1 by 3 81 t 3 to 2, 1 by 3, and then 81 into 3 minus 81 into 2. So we will get 1 by 3 into 81. This 3 and this is 27. So we will get the answer as 27 under root. So we will get the answer as 3 under root 3, right? 3 under root 3. RMS value. Now the unit of RMS value will also be this, right? So in this way you can calculate the RMS value. Simply you need to follow with the basic formula. For the average, for calculating the average, there is one more way. Like over here, when we can, over here we can calculate the area of this. So you can see the, if we calculate the area, this length it is 1 and this height it is 9. Okay, we will not take it as or we can take it as minus 9, right? Now the area, this area, it will be 1 into 9, it will be minus 9, right? It will be minus 9, minus 9, this is minus 9, and this total area over here in this time period of 3, total area is minus 9, because over here the area is 0. So 0 plus minus 9, total area is minus 9. Minus 9 divided by t, will give you the average value. So it is -3, and we also got this same answer. You can see over there, right? So it means you can use the basic formula also, and apart from the basic formula, because the physical significance, the main purpose of calculating the average power is this only, that we calculate the area, like we calculate that what is the total area within this. If we have a waveform, so we calculate the total area divided by time, but we can calculate the area only when the waveform is simple, like this type of rectangular waveform. Now coming to the second part of the question, which is this. Over here again we need to first determine the time period, means after which time the wave is repeating. Now if you look at this particular waveform, so over here it is starting from this point, right? And after that, like, it goes up, after up it goes till here, right? And after point 3, then again it is repeating down, up, and so we can say that this is our time period. It is 0.3, right? Now this point is 0.05, this point is 0.15, right? Now, and over here remember this is ft, so as such there is no unit, so we will not put any unit after calculating the average in the RMS value. Now over we also need to determine what is the equation of this curve, right, of this curve, and also the equation of this curve, so that we will substitute that over here in the RMS value and the average value, right? So if we calculate this thing, so simply we know that this point it is 0, 0, right? And this point it is, you can see it is 0.05 comma -1 comma -1, and we know these 2 points, we know this uh, 2 points a and b, so from this we can determine the equation. So the equation will be like, we can write y is our f, it is f, right? So f minus 0, simply following the rules to get the equation of the straight line, right? So it is f minus 0, and the slope is like 0, this y component minus -1 upon 0 minus 0.05, and x not x, t minus 0. So solving this, I will get f in numerator 1 upon minus 0.05 t, and again this dot, so it is 100, solving this it is 20, so it is f equals to minus 20 t, right? F is equals to minus 20 t for 0 less than t less than 0.05. Similarly, I will try to get the equation for this part, and over here I have two coordinates. One coordinate is this 0.15 comma 0, right? And this second point is this, which is on the x-axis we have 0.2, on the y-axis we have 1. Now having these 2 points, again we will try to calculate the equation. So this equation, it can be f minus 0, y minus 0, it is like something y minus y1 equals to y1 minus y2 upon x1 minus x2 right? This is the way we calculate the equation of the straight line. So following this, y minus 0 equals to y minus 0 equals to 0 minus 1 upon 0.15 minus 0.2 x minus 0.15, right? So it is f equals to 1 minus 1 upon minus 0.05 x minus 0.15, right? So this will become this minus minus cancel out, this 100 and then cancel, so it is 20. So f equals to 20 x minus 0.15, right? So this is the equation for 0.15 less than t less than equal to 0.2, right? So these are the two equations that we obtained, and for the remaining part we know that it is 0 and it is 0 over there, right? Now substituting this value in the equation, so again the average formula, right? Following the average formula, what formula I will get? I will get average is equals to 1 upon t2 minus t1. So it is t2 minus t1, so it is our t2, this is 0 is my t1, right? So 0.3 minus 0, integration from 0 to 0.3, and it dt, not it but it is ft, right? Because in this it is ft. Now substituting over here 1 upon 0.3, and this integration, like, it can be divided into two parts. One is from 0 to 0.5, right? Because we have two equations, 0.05, so it is minus 20t. So let me put it. It is 0.05 and it is 20t dt. Then the second is from 0.15 to 0.2, and the equation is this 0.15 to 0.2, and the equation is 20, not x, t, it is t, right? So we can substitute t over here, right? So 20 t minus 0.5, 0.15, 20 t minus 0.15 dt, right? So this we need to solve. Just a minute, let me check. Yes, it's great. And similarly let me put the RMS formula also at the same time. So RMS, it is, yes, the formula for the RMS, it is this. So following the same formula, first under root, now 1 upon t2 minus t1, so it will be 0.3, right? Then integration. Now this integration again, it can be split into two parts, right? So directly I will write two parts. First part is 0 to 0.05, similar to this one, right? So, and it, now this is ft, this is our square, right? So I will put minus 20t whole square dt plus this 0.15, 0.2, and then this will be the square 20 t minus 0.15, and this is whole square dt, right? And then this is whole under root. Now I need to solve this. So over here, first solving the average, this one. So it is 1 upon 0.3 integration. Now the integration of this, it will be integration of t. It is t square by 2. So we will get minus 10 t square. Limits is from 0 to 0.05 plus it is 20, and again 20t, it is 20t, or so it will be limits, it will be t square by 2. So it will be 20t, integration will be 10t square minus 20 into 0.5, 20 into 0.15, it will be it will be 3, right? It will be 3. So integration of 3, it will be 3t, right? And 3t, and the limits are from 0.15 to 0.2. Okay, now solving this further, 1 upon 0.3 first term, it will be minus 10 into 0.05 square, right? Minus 0, because of this 0 it will be 0. Then plus, substituting 0.2 in this, so we get 10 into 0.2 square minus 3 into 0.2 minus, now substituting this 0.15, so we get 10 into 0.15 square minus 3t, so minus 3 into 0.15, right? So it is this. So solving this, we will get 0.05, 0.05 square, it is 0.0025, right? Into 10, so it will be minus 0.025. This is 0, so nothing is required. Now this term, it is 10 into 0.2 square, 0.2 square, it is 0.04, so it will be plus 0.4 minus 3 into 0.2, so it will be minus 0.6. Now going further, it is minus 10 into 0.15, 0.15, 15 into 15 is 225, so it is 0.025, right? 0.225, 0.0225 into 10, so we will get minus 0.225. Then going further, this minus and this minus will become plus, so it will be plus 0.45, and this is under root, complete under root, right? That I forgot. Okay, this is the RMS value that we are getting, no? Yes, so no need of this, right? So over here, now solving this, okay, solving this, you will get 0.4, 0.6, so 0.2. Now minus 0.2, minus 0.2, and this minus 0.2. So this will become 425. Now minus 425 plus this 0.5, 0.45. So we will get means minus 0.45. So we will get 0.025. Now this 0.25 and this 0.25, like, so it will become, this will become, this will cancel out, so it will be, means this complete thing it will be 0, right, because this and this will cancel out. So it means if you just calculate all this, then this all this will become 0, and hence our average value it is 0. So this is our answer, average value. And this is what is expected also from just by looking at a diagram, because over here we have one triangle in the downward direction and equal triangle in the upward direction. So if we calculate the area of the of this one and of this one, then the top one it will be positive and the below one will be negative. When we add these two, then this will become 0. So we do not, like, we can come out with the answer directly by calculating the area also. Now similarly, if for the RMS value, if we calculate the RMS value, then it will be, now for this one the integration will be this expression, this internal expression, this it will be 400 t square, right? So its integration it will be 400 t cube by 3. So 400 t cube by 3, and the limits is 0 to 0.05 plus, now the next one over here again, if you look at this, the integration of this it will be this complete cube upon 3. So 20 t minus 0.15 cube. So this is cube, this is square, this remains square because it will come out of this. Over here we will take the integration of only the t side, right? So the coefficient of t will remain as it is, so 20 square, so it will be 3. So if you calculate the integration you will come out with this, and the limits is 0.2, 0.15, right? And if you solve this complete thing over here, just to save the time, so if you solve this at the end, you will get something as 1 by 9. Just a minute. 1 by 9 into 10 power. So something like one step I will write, it is, you will get something like 0.3 into 400 by 3, or let me write the direct answer. It will be 10 by 3, 400 by 3. Just a minute please. Yes, it will be 1 by 9 under root. So you will get RMS value as 1 by 3. So this is the answer, right? So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.